And next speaker, Christian Rohner from Uppsala University. Welcome.
Yeah, thank you.
Please go ahead.
No, thank you, and thanks to Vinnova for sponsoring this project. And the IoT is an attractive target for attacks because it has a big attack surface, and it is an attack can have high impact. The attack surface is big because we have limited resources, everything is connected, it's easy to access. And the impact is big because these devices are embedded into environments directly interacting with processes or the processes or kind of environments. And therefore it's important to protect systems from attacks, but also to detect attacks. And attacking attack is an important strategy to make this system safe. And we are looking in particular into data-driven intrusion detection systems. So based where we have training data that we use to train a classifier then that can distinguish benign and attack data. And in this project, we look in particular in two challenges with this approach. One is the data availability challenge. In order to train these systems, you need data, or it's very seldom that you have data available that you simply can use and then put into an environment. Often the data that is available is more normal traffic because the attacks that you have seen are probably very rare compared to all the possible attacks that can be put in. Also the low base rate, that means the low number of attacks compared to the normal data, leads intrinsically to a high false positive rate that we have to champion for. And there's also a challenge here that if we train a system in one environment, that we cannot by default just take it in another environment where the topology and everything is very different. So those are a few of the challenges that, the first challenge. And the second challenge is the data privacy or the privacy challenge. That if we have different actors that collect data in their environment, you often don't want to share this data with other actors. Partly because there's a stigma of releasing data about attacks that you have gone through, but also that the normal data includes so much information about the services and your topology that you don't really want to share that. So an established approach here is not to share the training data, but to share the model that you have trained with others. And therefore have a more privacy-preserving way to help each other and learn from each other's knowledge. There are approaches from federated learning and transfer learning that you can apply here. We are again facing a bit the challenge that we train in different environments, and it's not easy to just combine the data as traditionally done. And we are looking particularly at the moment into which features we have to use that are more robust for such transitions. I go now into two examples of a selection of results which show a bit the approaches that we take. In general, we want to generate a data set that can be used for training. And for that, we implement attacks, as previous projects also have presented. And in particular, and an interesting approach that we take here is that we also make attack variations. That means that the system doesn't just recognize the attacks that we have implemented, but we try to build a little bit a variation to that even unseen attacks from before can then be detected. Also, attackers might have or develop strategies to evade the defense mechanisms and the attack and the detection mechanisms. And in this example here, we implemented a black hole attack that is on the network layer, where you try to announce network metrics that are very beneficial to attract others' traffic that you then can drop. And instead of just doing it once, you can do it kind of an on-off way, or you can increase the intensity of your attack steadily. We have looked for that for 1 and for 2 attackers in different network topologies, and we see that in general, if we train a system on an attack, that the precision is quite good. That means that we have only few false positive. If you detect, it's really an attack. But the recall and therefore also the accuracy really struggle if we do these attack variations. And therefore we think it's important to include them as well in a training data. And the second approach that we take is based on generative adversarial networks, where you have a pair of a generator and a discriminator. And the role of the generator, or the idea there, is that you try to generate data that the discriminator is not able to distinguish from real data. And the classical example here are the handwritten digits from 0 to 9. And we said then one of the digits, the number 3, is our attacks, where we reduced the base rate and only used 2% of them, of those attacks in the data, and wanted to see how can we generate attacks that mimic, or the variations of attacks, and then look then, can these generated samples be distinguished or not from a normal classifier that is trained on limited data. And we see here in this confusion matrix that indeed if we generate these 3s, that they are more considered as an 8 than anything else, because this classifier hasn't been trained on enough of this attack data. These are 2 of the examples. We are at the moment also looking into observability, when you cannot observe all features or the whole network, and have limited data available for the detection of attacks. And we are looking for collaboration or for contacts with you that might have data or work on similar problems if you use AI in intrusion detection. And I would also like to announce that we have an open position for young researchers as assistant professor with a deadline in March. Thank you.